to my channel. I'm Arjun Abalanag, and our topic for today is all about AI and cybersecurity. First, for AI or artificial intelligence. Let's go. AI or artificial intelligence is all around us. Whether we know we're interacting with it or not, AI refers to a collection of technologies that allow computers to sense, learn, reason, and act. But a far cry from the sci-fi promise of a humanoid robot that thinks like us. AI is currently only capable of specific individual tasks. AI powers that algorithms, the instruction encoded in the computer programs, the ranked search result on the web, tag your friends and photos online. Let a smart assistant understand the word you say and recommend which movie to watch next. AI can help to detect disease, identify fraudulent credit card purchases, and monitor threatened ecosystem and wildlife. How does AI work? One approach is called machine learning, equipped with algorithms and vast amounts of data called database. AI developers train computer programs to recognize patterns and tackle complex problems. In many cases, machine learning algorithms called neural networks extract information from examples in the training dataset by searching for patterns and multiple steps called layers. Once a program has been trained on a dataset, can be encounter new scenarios and start making predictions. For example, if the training dataset is a collection of labeled images of cats and the algorithm instructs the program to identify a cat, a successful image recognition program could then correctly classify a new image as either a cat or not a cat. If a language generator were successfully trained in all of the English text library's collection of books and articles, it could then compete and unfinish while obeying the rules of English grammar. This process is not transparent. We have yet to design algorithms universally capable of explaining how they arrive at a particular answer, so we cannot know exactly what makes our program so it sees a cat, or how exactly it knows that whom it corrects, not who. Just applying the instruction, being shown a huge number of examples. AI is expressive but not perfect. Flaws reflect the data we choose to train all algorithms. The flaws as well other choices made by the humans who develop these technologies and send them out into the world. Some of these flaws, like those in tools that determine credit score, evaluate access to healthcare, and then attempt to predict crime, greatly impact human lives. That essential training dataset is a key point of weakness, where assumption and biases of frequently sneak in. Here are some real-world examples where incomplete or unbalanced training dataset causes unfair outcomes, and self-driving car might not be able to identify a person using a wheelchair in a crosswalk, and wheelchair users were not included in the data when it was trained. Facial recognition program trained on image that distinctly represent faces with lighter include people with darker skin tones. We have the power to reduce this embedded bias by creating AI training dataset that mirror the complexity of the real world, to lead equitable, inclusive outcomes, and by building a diverse workforce and AI developers and decision makers. We must also consider social, economic, and ethical priorities when deciding which problems to tackle with AI in the first place. Each of lives in the world filled with AI. The more we all know about where and how these technologies influence our lives, the better we can do advocate for ourselves and reach for a more equitable world.
What is cybersecurity, and how does it protect you? Cybersecurity is the front line of defense against attacks on computers, servers, mobile devices, electronic systems, and networks. Attacks come through the internet. Cybercrimes are perpetrated by criminals who target individuals or networks for financial gain or to cause service disruption. Cyberterrorism is another type of attack. It's where technology is used to inflict real-world damage or cause critical disruption to infrastructure. If you go online using any electronic device, you are susceptible to cyber attacks and need some form of cybersecurity. How do cybercriminals and hackers launch cyber attacks? A common threat is malware, or malicious software. Malware comes in various forms. A virus infects files with malicious code. A Trojan causes damage or collects data. Spyware records a user's activities, which means it can capture credit card details. Ransomware locks files and data. Cybercriminals threaten to erase them unless a ransom is paid. Adware spreads malicious code through tempting advertisements. Botnets are networks of computers infected with malware. They enable cybercriminals to perform tasks online without the user's permission. Other cyber attacks come in the form of phishing. This is an email or message that requests personal information, such as passwords or credit card numbers. SQL injection inserts malicious code into a database. SQL injection inserts malicious code into a database. This gives hackers access to sensitive information. Man-in-the-middle attack is where a cybercriminal intercepts communication between two users in order to steal data. Denial of service attack is where a network or server is overwhelmed with traffic, preventing the system from performing its regular functions. While those affected the most from cyber attacks are retailers and medical providers, public services, individuals are still at risk. And it only takes one person to accidentally download malware onto their company's network by not adhering to simple security practices. How can you protect yourself and your employer from cyber threats? Updating the operating systems and software on your devices.
First, in the second video, we discuss what is AI and what is cybersecurity means. So, the main topic for today is all about AI and cybersecurity. So, let's go.
Important topic of AI and cybersecurity. As technology advances and cyber threats become more sophisticated, it's crucial that we explore the potential benefits and challenges of using AI and cybersecurity. This video will provide a comprehensive analysis of this topic, examining the opportunities, challenges, and ethical implications of using AI and cybersecurity. In recent years, the use of artificial intelligence, or AI, has become increasingly prevalent in various industries, including cybersecurity. AI has the potential to revolutionize the field of cybersecurity by providing better threat detection, faster response times, and increased accuracy. However, the integration of AI in cybersecurity also presents new challenges and risks that must be carefully considered. One of the main benefits of using AI in cybersecurity is its ability to detect and respond to threats in real time. AI algorithms can analyze vast amounts of data, including network traffic, system logs, and user behavior, to identify potential threats quickly. Machine learning algorithms can also learn from past incidents to improve their accuracy over time, making them more effective at detecting new and evolving threats. Furthermore, AI can help automate routine security tasks, such as patching and updating software, freeing up cybersecurity professionals to focus on more complex issues. This can improve the overall efficiency of cybersecurity operations and reduce the likelihood of human error. Despite these advantages, the integration of AI in cybersecurity also presents new challenges and risks. One of the most significant concerns is the potential for AI systems to be manipulated or deceived by attackers. Adversaries can train machine learning algorithms with false data or use adversarial techniques to evade detection by AI systems. For example, an attacker could use a technique known as poisoning to introduce false data into an AI system's training dataset, which can cause the system to make incorrect decisions or fail to detect threats. Attackers can also use adversarial techniques to generate malicious inputs that can bypass an AI system's detection capabilities. Another risk associated with the use of AI in cybersecurity is the potential for privacy violations. AI algorithms can analyze vast amounts of data, including personal information, to detect potential threats. However, the use of personal data raises concerns about privacy violations, particularly in cases where the data is collected without the user's consent. To mitigate these risks, cybersecurity professionals must carefully evaluate the effectiveness of AI systems and implement appropriate safeguards to protect against potential attacks. This includes developing robust testing procedures to detect and prevent adversarial attacks and ensuring that AI systems are trained on high-quality, representative datasets that are free from bias. Furthermore, it's crucial to ensure that the use of AI in cybersecurity complies with relevant laws and regulations, particularly those related to privacy and data protection. This includes implementing appropriate measures to ensure the confidentiality and integrity of sensitive data, such as encryption and access controls. In addition to the risks mentioned above, another challenge associated with the use of AI in cybersecurity is the lack of transparency and explainability. Machine learning algorithms can be complex, making it difficult for cybersecurity professionals to understand how the algorithm arrived at a particular decision. This lack of transparency and explainability can make it challenging to identify and mitigate potential errors or biases in the system. To address this challenge, researchers are developing new techniques for interpreting and explaining the decisions made by AI systems. For example, techniques such as LIME, Local Interpretable Model-Agnostic Explanations, and Shapley Additive Explanations, can be used to provide insights into the factors that contributed to a particular decision. These techniques can help cybersecurity professionals identify and address potential biases or errors in the system and improve its overall accuracy and effectiveness. Another potential benefit of using AI in cybersecurity is its ability to facilitate threat intelligence sharing and collaboration. By analyzing data from multiple sources, AI algorithms can identify patterns and threats in cyber attacks, enabling cybersecurity professionals to proactively defend against emerging threats. Furthermore, AI can help automate the process of sharing threat intelligence between organizations, allowing for faster and more effective responses to cyber threats. Despite these potential benefits, the use of AI in cybersecurity must be approached with caution. It's essential to carefully evaluate the effectiveness of AI systems and ensure that appropriate safeguards are in place to protect against potential attacks and privacy violations. Additionally, cybersecurity professionals must remain vigilant in their efforts to detect and respond to emerging threats, as attackers continue to develop new and sophisticated techniques for evading detection by AI systems. Another challenge that arises with the use of AI in cybersecurity is the ethical implications of its deployment. As AI systems become more autonomous and make decisions on their own, questions arise regarding their accountability and responsibility in the case of cybersecurity. If an AI system fails to detect or respond to a threat, who's responsible for the consequences? Moreover, the use of AI in cybersecurity can have unintended consequences such as perpetuating biases and discrimination. AI systems learn from the data they're trained on, which can reflect societal biases and prejudices. If this data is used to train cybersecurity algorithms, it can perpetuate these biases and result in discriminatory outcomes. To address these ethical concerns, it's crucial to develop guidelines and best practices for the responsible use of AI in cybersecurity. This includes ensuring that AI systems are designed to be transparent, explainable, and accountable, and that they're trained on diverse and representative datasets. Additionally, cybersecurity professionals should be trained to understand the ethical implications of using AI to evaluate the potential impacts of AI deployment and different stakeholders. Another area where AI can be leveraged in cybersecurity is the field of deception technology. Deception technology involves setting up decoys or traps to mislead attackers and divert them from the real targets. AI can be used to enhance deception technology by analyzing data from various sources to identify potential attack vectors and creating realistic decoys that can deceive attackers. This can improve the overall resilience of a system and make it more difficult for attackers to carry out successful attacks. In conclusion, the use of AI in cybersecurity presents both opportunities and challenges. While AI can provide faster threat detection and response times, it also raises concerns about privacy, transparency, and accountability. By adopting a responsible and ethical approach and implementing appropriate safeguards, cybersecurity professionals can maximize the benefits of AI while mitigating its potential risks. Additionally, the use of AI in deception technology can provide an effective defense against cyber threats, making it an area that merits further exploration and research.